Hi, in the previous chapters we have studied about the elements, its compounds, its molecules and so on, right? Such as hydrogen, oxygen, nitrogen and so on. Now, in all there are 118 elements which have been discovered so far. Now, in early 19th century there were just around 30 elements which were discovered, and to study them a proper classification was required. Now, first you need to understand why a classification is required. Now, imagine yourself in a classroom of 100 students of all different standards. Now, is it possible for the students to study in that classroom? I guess the answer is no, right? Because a teacher cannot teach all the type of students together. Each student have different properties, they have different sense of understanding and so on. Okay, so as the properties of all the elements are different, they cannot be put all together. They need to be properly classified into different groups or different categories. Now, there are different scientists which try to classify the elements in their own way. Let us have a look at them.
In 1817, a German scientist, Bourboneau, was one of the first scientists to come up with any type of classification of elements. Now, what he did is he arranged the elements in the ascending order of their atomic mass, and then he made a group of three elements, which he called it as triads. So, he observed a very interesting phenomena that the atomic mass of the middle element is almost equal to the average of the atomic masses of the other two elements. For example, if we consider lithium, sodium and potassium, if we take the average of atomic mass of lithium and potassium, it will come almost equal to the mass of sodium. He observed such phenomena in many such elements, in many such triads, and in this way he was able to group many of the elements which were known at that time. But the main drawback of this type of classification is that it did not include all the elements known at that time. It cannot classify all the elements into triads, and hence this method was not widely accepted. Another such well-known scientist was John Newlands, who tried to classify the elements in a very unusual way. What he did is he arranged the elements in the ascending order of their atomic masses, and what he observed that every eighth element has the same chemical properties as the first one. For example, if you start from lithium, sodium will be the eighth element, and lithium and sodium will have many similar properties. Again, if you start from fluorine, the eighth element from fluorine will be chlorine, and chlorine and fluorine have many similar properties. And he tried to match up this number 8 with the musical octaves. Okay, musical octaves, these are the sounds of sargam, we can say sa re ga ma pa dha ni sa, right? The sa, the eighth sound of sargam, is actually the first itself. So he arranged the elements in the table of the octaves so that every eighth element will come on the first note again, and elements in each note have similar properties. Now, this method of classification was also not well accepted by many of the scientists because of the following drawbacks. The Newlands law of octaves was only applicable till calcium. After calcium, the law wasn't applicable for many of the elements. Now, to accommodate all the known elements at that time, he had to take more than one element in a single box. So this type of classification was also not accepted by many of the scientists. Now, some elements with different properties were placed in the same node. For example, if you see cobalt and nickel, these are actually the metals, and chlorine and fluorine, these are actually the halogens. Their properties are not same, but they are in the same musical node. Whereas cobalt and nickel, being metal, should be placed with iron, which is in the last node. These are the elements having similar properties but placed in the different nodes. Also, there was no provision to add up any more elements which were being discovered at that time. Due to these drawbacks, this classification could not move further. Now, the major breakthrough in the classification came in 1869 when Mentaly proposed his theory. Now, what Mentaly did is he arranged the elements in the ascending order of the atomic masses. He studied the molecular formula with the oxides and the hydrides. He studied their boiling points, their melting points, the density of elements. So in short, he studied all the physical and the chemical properties of the elements, and then he placed them in the table with respect to their properties. So by this classification, he was able to come up with his table where all the elements having similar properties are placed in the same group. If you look at the first group, it contains hydrogen, lithium, sodium, potassium. These are all having similar properties and hence they are placed in the same group. So this classification was very widely accepted by most of the scientists due to these following merits. Now, prior to Mendeleev, it was assumed that the mass of beryllium is 14.09. But after Mendeleev had thoroughly studied the chemical and the physical properties, he found out the mass of beryllium should be less than boron. Hence, he placed beryllium before boron in the table. And after a few years, by experimental process, it was found out that the mass of beryllium is actually less than boron. It is just 9.5, while the atomic mass of boron is 11. Hence, the table was able to predict the approximate mass of the elements as well. Now, he has also kept some vacant spaces between few elements, which were to be discovered in future. For example, there's a vacant space between calcium and titanium. The atomic mass of calcium is 40, where the atomic mass of titanium is 48. There's a large gap between these two atomic masses. So Mentaly thought there should be an element with the atomic mass 44. Hence he purposely kept a gap in between for the element to be discovered. So this table also had a provision to predict which elements will be discovered in future. Okay. Now Mentaly, when he proposed this table, the inert gases or the noble gases were not discovered at that time. And once they were discovered, what Mendeleev did is he prepared another column for them so that they won't disturb the placement of the other elements. Now, due to all these merits, the Mendeleev's table was widely accepted by all the scientists. But in spite of that, there were a few demerits of Mendeleev's table. The whole number mass of cobalt and nickel is the same. You can see in the last group, cobalt and nickel have the same, almost same atomic mass. Hence, there was a confusion regarding which element should be placed before the other. The isotopes were discovered later and they had no place in this table. Now, the isotopes are actually the same atoms with different atomic mass because they have different number of neutrons in them. Okay, you can see these are the three isotopes of hydrogen with different atomic mass 1, 2 and 3, and hence they should be placed in the table because the arrangement was according to the atomic mass, but all the isotopes could not find any place in this table. Now another important drawback was that the elements were placed in the ascending order of the atomic masses, but the difference between the atomic masses was not uniform. You can see that the difference between the atomic mass of boron and carbon is 1, whereas the difference between the atomic mass of carbon and nitrogen is 2. You can see in the complete table the difference between the atomic masses of the consecutive elements was not same. Hence it was difficult to predict how many elements are yet to be discovered between two heavy metals. Also, an important drawback was that hydrogen showed similarity with chlorine and fluorine, whereas it was placed with sodium and potassium. Now, hydrogen has a similarity with alkali metals as well as halogens. Hence, there was again a confusion where should be the exact position of hydrogen. In spite of all these drawbacks, Mendeleev's periodic table was an important step in making of the modern periodic table.
Now, all the previous scientists which tried to classify the elements were not successful. Their theories weren't accepted. But Mendeleev's was the only one whose theory was properly well defined because he studied all the chemical as well as the physical properties of elements, and then he classified into his table. And that was the first step towards the making of the modern periodic table.